So, hello everyone, my name is Resuello Mark Jesse from NS1A3. So, in this video, I'm going to discuss or solve the great circle distance, initial course, final course, latitude vertex, dilo vertex, and track the great circle in every 10 degrees and total distance of track. So, this is our scenario. You are going to determine the waypoints to use along the great circle track or GCT from 35 degrees north, 7 degrees west, and the arrival position of latitude 39 degrees north and longitude 74 degrees west. So first, we are going to list the departure position. So latitude. Zero, 7 degrees. And then also we need to list the arrival position. So after that, we need to solve it. So in getting the DLAT and DLong, there is a rule to apply in same name, subtract, and different name, addition. So in this, departure and arrival, we have the same name, so we need to subtract it. So the answer will be 04 degrees north. And then the DLong have the same name also, so we need to subtract it. So the answer will be 67 degrees west. So next, we are solving for the great circle distance. So here's our formula. Cosine GCD is equal to, open parenthesis, cos lat 1 times cos lat 2 and times cos DLO, close parenthesis, addition or subtraction, open parenthesis, sin lat 1 times sin lat 2 and close parenthesis. So we are using the plus parenthesis or addition because we are not crossing the equator, and lat 1 and lat 2 are both north, so that is the reason why we need to use addition. So now we are using our scientific calculator to get the equivalent. So we need to input cosine 35 degrees and the answer will be 0.81915. So next one is the cosine latitude 2. So cos 39 degrees equal to 0.77715. And then next, cosine DLO. Cos 67 degrees equal 0.39073. So after we get the equivalents, we need to multiply these three. So we need to use our calculator to multiply those three. 0.81915 times 0.77715 times 0.39073. So the answer will be 0.24874. So next one is we are substituting the sin latitude 1 and sin latitude 2. So again, we are using our scientific calculator. So input sin 35 degrees. So this is the answer, 0.57358. And then, in sin latitude 2, sin 39 degrees equal to 0.62932. And then, we need to multiply these two. So, 0.57358 times 0.62932. So, the answer is 0.36097. So, the next step that we need to do is add these two, 0.24874 and 0.36097. So, using our calculator, 24874 plus 0.36097. So, the answer will be 0.60971. So, we are not done yet. After we getting the answer is we need to press shift, cosine, answer, and equals. And then press the degrees. So, we are now have 52 degrees 25 minutes point 53.27. So this is the distance angle. So after that, we need to divide 53.27 into 60. So, using our calculator, so now, 53.27 divided by 60, the answer will be 0.88 or 0.9. And then now, we have the distance angle of 52 degrees 25.9 minutes. So now, we are getting the great circle distance. So this is the formula. GCD is equal to distance angle times 60. So first, we need to substitute the distance angle. So, 52 degrees 25.9 minutes multiplied by 60. So, input it into our calculator. 52 degrees, 25.9 degrees times 60. So, the answer will be 3145. And then click the degrees. So, the answer will be 3,145.9 nautical miles. So that is the GCD. So now we are solving for the initial course. So this is a formula. Sin IC or initial course angle, open parenthesis, cos latitude 2 times sin dilo close divided by sin distance angle. So first we need to substitute it. So now we are, so after listing we need to put cos latitude 2 cosine 39 degrees is equal to 0.77715. And then the other one, sin 0.67 degrees equal. So the answer is 0.92050. After we get the equivalent, we need to multiply these two. So, 0.77715 times 0.92050 is equals to 0.771537. So, after we get this product, we are looking for the equivalent of sin distance angle. So, input into our calculator. Sin 52 degrees, 25.9 degrees equals to 0.79263. So now, we are going to divide these two. So, in our calculator, 0.71537 divided by 0.79263. So, the answer is 0.90253. So, the name is Northwest. Why Northwest? Because the rule in initial course names is same as latitude 1, which is north, and Dilo is west. So that's why Northwest. So after that, we need to get the initial course angle. So we need to input shift sin answer. So now we have 64.493. Northwest. So now we are performing the quadrant rule. So quadrant rule in Northwest. So this is the formula. Northwest is equal to 360 minus course angle is equals to true course. So now we need to substitute it. 360 and then substitute the course angle, which is 64.493, and then we need to calculate it. 360 minus 64.493. So the answer is 295.507. So the initial course is 295.507. So now we are solving for the final course. So this is the formula. Sin FC or final course angle, open parenthesis, cos lat 1 times sin Dilo, close, divided by sin distance angle. So first we need to substitute. Cos lat 1 is equals to 35 degrees. And then we need to input that in our calculator. Cos 35 degrees. So the answer will be 0.81915. And then also in the sin Dilo. So sin 67 degrees is equals to 0.92050. After that, we need to multiply these two. So 0.81915 times 0.92050. So the answer will be 0.75403. So now, we are solving for the sin distance angle. So, substitute it. Sin 52 degrees, 25.9 minutes is equals to 0.79263. After that, we need to divide these two. So 0.75403 divided by 0.79263. So put in our calculator 0.75403 divided by 0.79263. So the answer is 0.95130 southwest. 0.95130 southwest. So why southwest? So because there is a rule is labeled opposite the name of latitude 2 and same as Dilo, so southwest. So after getting the final course angle, we are now proceeding to the quadrant rule. So we are looking for the southwest because it is indicated in our final course angle. So quadrant rule, here is our formula. Southwest is equal to 180 plus course angle equals to true course. So we need to substitute it. So southwest equals to 180 plus 72.045. So we need to input that in our calculator. 180 plus 72.045. So the answer will be 252.045. So the final course is 252.045. So now, let's solve for the latitude vertex. Here is the formula for latitude vertex. Cos lat vertex equals cos lat 1 times sin initial course angle. So first, we need to input in our calculator the cos lat 1, cos 35 degrees and equal. So the answer is 0.81915. So next one is we need to get the value of sin IC angle or initial course angle, which is 64.493. So we need to input that in our calculator. Sin 64.493 is equals to 0.90253. After we get these two values, we need to multiply it. So we need to input it in our calculator. 0.81915 times 0.90253. So the answer will be 0.73931. And the name is north. So why north? It is north because latitude 1 and latitude 2 is both north. So after we get this product, we need to press in our calculator, shift cos, and then answer equals, and then degrees. So now we will have the 42 degrees, 19 and 38.38 minutes. So we are not done yet. We need to divide the 38.38 into 60. So divided by 60, we need to use calculator. 38.38 divided by 60. So the answer is 0.6. So now, latitude vertex is equal to 42 degrees 19.6 minutes. So now, after we get the latitude vertex, we are now solving for the difference longitude vertex or Dilo vertex. So here is the formula for Dilo vertex. So sin Dilo vertex is equal to cos IC angle divided by sin lat vertex. So we need to substitute it. So cos IC angle is equal to 64.493. And then sin lat vertex, so here's the latitude vertex, 42 degrees 19.6 minutes. So after that, we need to input it in our calculator. So first is the IC angle. So cos 64.493. So now we have the 0.43062. And then next is the sin lat vertex. So sin 42 degrees 19.6 degrees. So the answer is 0.67336. So after that, as said in the formula, we need to divide these two. So using our calculator, we are going to divide it. 0.43062 divided by 0.67336. So now, here is the answer. 0.63951. So now we need to write it. So 0.63951. So the name is west because both of our longitude is named as west. So we are not done yet. So after that, we need to press in our calculator shift, sin, ans, equal, and degrees. So now we will have 39 degrees, 45, and 19.05 minutes. That is the difference longitude vertex. So we are not done yet. After that, we need to divide the 19.5 to divided by 60. So we need to use our calculator. 19.5 divided by 60. So the answer is 0.3. So now, difference vertex, longitude vertex is equals to 39 degrees 45.3. So now, we are going to track the great circle in every 10 degrees. So the first thing that we are going to do is list the departure position, which is the latitude 0, that is 35 degrees north, with a longitude of 7 degrees west, and also write the arrival position in the table, which is the latitude 8, 39 degrees north, with a longitude of 74 degrees west. So the next step is we need to do is we will track the great circle in every 10 degrees. So in longitude, we have the 7 degrees west, and then put in the table under is 10 degrees west, 20 degrees west, 30 degrees west, 40 degrees west, 50 degrees west, 60 degrees west, 70 degrees west, and until we reach the arrival position, which is the 74 degrees west longitude. Because we need to track the great circle in every 10 degrees. So after we get the longitudes, we are now going to solve or to get the longitude 1, which is the 36 degrees 7.2 north. So let's solve it. So first, write the longitude 0, which is the 07 degrees west. Remember, this is a constant. So next, write the longitude 1, which is the 010 degrees west. So in this rule, if they have the same name, you need to subtract it. And different name, you need to add it. So as you can see, they have the same name. So you need to subtract it. And then, if you subtract it, we will have a DLO of 003 degrees west. So next, write the DLO vertex that we have solved earlier. So the DLO vertex is a constant. We only just change the longitude 1. So in this part, we have the same name, so subtract it. So subtract the 003 degrees west and the DLO vertex of 39 degrees 45.3 minutes west. So we will get the DLO vertex of 36 degrees and 45 minutes 0.3 west. So now we have the formula here. Tan lat x is equal to cos DLO vertex times tan lat vertex. So we need to perform it. So first, we have the cos DLO vertex, which is 036 degrees 45.3 minutes. So we need to input that in our calculator. So cos 36 degrees 45.3 degrees and equals to 0.80120. So next one is the tan lat vertex. Remember, tan lat vertex is a constant. So let's solve it. So tan 42 degrees 19.6 degrees. So we will have the 0.91078. After that, we need to multiply these two. So 0.80120 times 0.91078. So the answer is 0.72972. So we are not done yet. So after we get this product, we are now need to click the shift tan answer equals and then degrees. So now we will have the latitude 1 of 36 degrees, 7 degrees, 8.32. So we need to divide 8.32 into 60. So we will have the answer of 0.2. And then the latitude 1 is 36 degrees, 0.72 north. So we are already get the latitude 1. So now, after we get successfully the latitude 1, we are now having another example. We are now getting the latitude 2. So now, latitude 2. So we have a constant long 0, which is 7 degrees west, and then we need to list the longitude 2, which is 20 degrees west. So remember the same name, so we need to subtract it. So now we will have a DLO of 13 degrees west. After that, we need to write the DLO vertex, which is constant. So 39 degrees 45.3 west. So same name, so we need to subtract it. So now we will have a DLO vertex of 26 degrees 45.3 west. So now, after we get the DLO vertex, we need to perform this formula. So let's have the cos DLO vertex, which is 26 degrees 45.3, and then we need to input it in calculator. So cos 26 degrees 45.3 degrees. So as you can see, we got 0.89294. So write the answer. And then next, we get the tan lat vertex. which is 42 degrees, 19.6. So, insert it in a calculator. Tan 42 degrees, 19.6 degrees, and equal. So, now we will get a 0.91078. So, after we get the answers, we need to multiply these two. So, 0.89294 times 0.91078. So, now, we will have the answer of 0.81327. So, after we get this product, we will click the shift tan answer equals and then degrees. So now we will have a latitude 2 of 39 degrees 07 13.76 minutes, and then the 13.76 minutes is divided by 60, so we will have 0.2. So now we will have the latitude 2 of 39 degrees 07.2 minutes north. So now we are successfully getting the latitude 1, which is 36 degrees 07.2 minutes north, and the latitude 2, which is 39 degrees 07.2 minutes north. So you need just continue until you reach the arrival position. So now we are getting or try to solve the course and distance. So now, let's have the example of course 1 and distance 1. So first, write the latitude 0, which is the 35 degrees 00 north, and latitude 1 with value of 36 degrees 7.2 minutes north. So we need to solve it in our calculator. So we need to subtract it. So, 35 degrees minus 36 degrees, 7.2 minutes. So, the answer is 1 degrees, 7.2 minutes north. So, that is the daylat. .2 minutes. So, after that, we need to multiply it by 60. Remember, 60 is a constant. So let's multiply it. So now, we will have the answer of 67 degrees 12 minutes or 67.2 minutes north. So now, we are now getting the MP. So the formula in MP is MP equals log open parenthesis tan open parenthesis slat divided by 2 plus 45 and 2 close parenthesis, and times 7,915.7 minus open parenthesis 23.3 times sin open parenthesis lat and close parenthesis. So now we are going to solve for the MP1, which is the lat 0. So let's start. So in our calculator, we will insert the log open parenthesis tan open parenthesis the latitude, which is the 35 degrees. So 35 degrees divided by 2 plus 45 and double close parenthesis, and then times 7,915.7 minus open parenthesis 23.3 times sin open parenthesis the latitude, which is 35 degrees and close parenthesis. So now we will have the answer of 2,230.92. which is here. So now, we are now going to solve the latitude 1 or the MP2. So now, insert same formula. Log, open parenthesis, tan, open parenthesis, the latitude which is 36 degrees 07.2 minutes north. So 36 degrees 07.2 degrees divided by 2 plus 45 and double close parenthesis and times 7,915.7 minus open parenthesis 23.3 times sin open parenthesis the latitude which is the 36 degrees 07.2. So 36 degrees 07.2 degrees and then double close parenthesis. So now we will have the answer of 2,313.15 or round up, so 0.16. So now they have the same name, so we are going to subtract it. So we will have the 82.24 DMP. So now we are going to solve the true course. So here is the formula. Tan course angle is equal to D low that we are solved earlier, and then the DMP which is we solved here. So we need to substitute it first. So D low is equal to 180. So divided by DMP which is 82.24. So we need to divide it. 180 divided by 82.24. So we will have the answer of 2.18872. So 2.18872. So we are not done yet. So to get the course angle, we need to click the shift, tan, answer, and equals. So we will have a 65.44. The course angle is 65.44 northwest. So how we say the name is northwest? Because the D-lat is north and the D-long is west. So that's why the course angle is northwest. So next step is we need to get the quadrant rule or solve the quadrant rule. So here's the formula. Northwest is equal to 360 degrees minus course angle is equals to true course. So let's substitute it. So 360 minus the course angle which is 65.44. And then after that we need to use our calculator. So 360 minus 65.44. So now we will have the answer of 294.56 or 295 because it is round off. So let's write the answer. So now we will have the true course of 295. So now we're going to solve for the distance. So here's the formula. Distance is equal to D-lat divided by cosine course angle. So let's substitute it. So D-lat is equal to 67.2 divided by cos 65.4. And then we need to use calculator. So 67.2 divided by cosine 65.4. So now we will have the answer of 161.42 or 43 because it is round off. So let's write the answer. So that is the distance, nautical miles. So now, after we successfully solve the course 1 which is 295 with the distance of 161.43. You just need to fill all of this. And then we are going or proceeding to the last part, which is getting the total distance. To get the total distance, you just need to add all of this. So let's start and use our calculator. So 161.43 plus 509.2 plus 499.5 plus 420.8 plus 439.3 plus 452.8 plus 467.5 plus 194.3. So now, we will have the total distance of 3,144.8. So, that is the total distance. So, that's it for our discussion. I hope learned something. So, again, I'm Resuello Mark JCV from NS1A3. Thank you for watching.